Hey guys, welcome to the Tech Granth. So today we'll have the hands-on session. It was due for some time now, and we'll do hands-on session on Q. So in this particular session, I will go through how you can create a Q data structure using an array. And yes, do like and share the video, subscribe to the channel to get further update. So let's jump into the queue. So like in my previous video on data structure for beginners queue, I told that queue is a data structure which follows first in first out kind of mechanism. So suppose this is kind of the number which is flowing into the queue. So since one came first, so one will be processed first, then two came, so two will be processed, three came, then three will be processed, and four came, so four will be processed. It will follow that structure. So how we can uh, create this data structure using an array, that is what I'm going to show you here. So we'll create an array of integers. So we'll create a queue of integer here. Basically I will say array is equals to new int, and for now I will create a queue which can hold size 100. You can create of size more than this. Basically you can go until the maximum size of integer. And since queue data structure does not require you to define what is the size of the structure, or what is the size of the queue data structure when you define queue, so underlining you can just go on till you have memory. So you can basically go on till the maximum size of integer. For demo purpose I am picking size of 100. Then you will have two pointers. One will be front, which will be 0 initially, and one will be rear. So as you know, in queue data structure, uh, from one end you will insert the data, from the other end you will pull it out. So from rear end you will insert the data, and from front you will pull it out. So if we have if we have this structure where one came first, so this will be my front. So just let me comment this out. So if this is the queue, so this part will be my front, and this will be my rear. So when I inserted a record, I inserted it in the rear, and I incremented my rear one by one. So that is how this data structure looks. So we need to basically create three functions here for queue data structure to work. One will be to enqueue, where you add an element to the queue. Other will be dequeue, where you get the element or pull the element out of the queue. And the third one will be the top element or the front element in case of queue. So let us first create the enqueue method. So in enqueue you will receive an integer value, and you need to add it in my queue, or you need to add it in this queue data structure. So when you do an enqueue, you need to check whether the size has been reached. So you will do a check whether your rear is equal to array dot length minus 1. If it has reached, then you simply return, because you cannot, or and you can also put the message that queue is full, something like this. If this is not the case, in that, then what you can do is, then you can simply say in my rear, array of rear is equals to this value, whatever value that has come, and you will make rear plus plus. So when you enqueue all these numbers, so in my array 1 2 3 4, these will be inserted, and my initially my rear will be here. My rear will be pointing to 1. So when I don't have anything, now when I inserted 2, so I will make my rear come to 2, and my front will be at 1. Initially the both front and rear was at 2, or at 1, sorry. Now when I inserted 2, so my front will be at 1, my rear will be at 2. When I insert 3, so my rear will again move, my rear will come to 3, and my front will still be at 1. when I insert 4, so my rear will again move and it will come to 4 and my front will be at 1. Now if I DQ, when I do a DQ, that time I need to remove this 1 and I need to adjust my front. I need to bring the front here, or the other way we can do is we can simply remove 1 by bringing all these elements one step before and bringing this rear also to this particular to one step beforehand. Okay, and this we can make it as 0, which is the default value of int. So I hope this is pretty clear to you. So this is how NQ operation will work uh, for us, and now we will do DQ. Or before that, I will simply do a private static void main q is equals to new q, and I will say a dot nq. I will nq1 and I will nq1, and we can implement basically some mechanism to print the value of this q. So I will just say private void print q. So in print q will go current I equal to 0, I less than equal to rear, will go till the rear element and we will print it, right? So we'll print array of I. So this is what we'll do, and here I can say a dot you print my q. So if I run this now, so you see actually no need to go till the end, it will be less than, sorry, my mistake. So we have just 1 here in the queue currently. Now if I add one more element or few more elements, may add 2 3 4, and I will run it again. So we have all these 4 elements in my queue. So all these elements are queued one after the other. Now that is how we will enqueue. Now next thing is dequeue. So when I have to do a dequeue, when I dequeue, I basically return the value of the front element. So I will say dequeue, and I need to implement the dequeue. So when you implement dequeue, you remove the element from front. So what you do is we will return array of front. Okay, so this is what we need to return when we do a dequeue. Now when we do a dequeue, we have removed this one, we have removed this one from the queue. So now the front has to be adjusted. So front will always be at 0. What we'll do is we will move all these elements towards left hand side. So we'll just copy all those elements towards toward the left hand side. So what we can say is int will take a temp, and temp will have this value, temp will have this front, and we'll do for I equal to 0, or we'll start from 1 and we'll go I less than rear I plus plus, and here what we will do is array of I minus 1 is equals to array of I. This is what we will do. We'll just copy all the elements towards the left hand side. We'll copy each element here. So front will still be at the 0th position, and from here I will say you return the temp, whatever temp I had initially, and before returning we need to do rear minus minus, because now my rear has moved from this 4th position to this 3rd position, right? So that is how the dequeue operation should work. So if I say after 4 a dot dequeue and I run this, so you see the 1 is gone now. If I do another dequeue here, So now 2 is gone. That is how the first element that came, that is removed first, then 2 came, so 2 is removed first when I did the dequeue. So this is the way of by using these two variable front and rear, you can implement a queue data structure. You can implement a queue data structure in Java. And one more thing that you can check is and you can add one more element here, one check here, that if front is equals to, or sorry, the rear, if rear is less than 0, in that case we'll simply return so this is enqueue, I'm doing it in the wrong place, it should be here. So you return -1, and you can here print that queue is empty. This is one check you can just put, because if no element is there and you want to dequeue, so you should return -1. And finally we will implement one more method that will be uh, this will be boolean, and it will be called front element, or you can just say front. So this will give you what is the element which is present in the front. So, and I'm sorry, this will not be boolean, this will again be int. So you just need to return here array of front. You don't need to do anything, you don't need to populate, or don't need to change. So you just need to return this part, and you again you need to make the same check. I will just copy paste here. If the rear is less than 0, so it means queue is empty, you return -1, otherwise you will return the front element. So if I, after doing a dequeue, I do front element, so here it should return me 3 now, right? So I need to put it in system.out, so you print here front element is so front element is 3, and it printed 3 and 4, whatever is there as part of the queue. So this is it for the session. So this code is present in my Git repository. The link is there in the description. If you go to my Git repository, I have two modules there. One is for data structure, where I have the hands-on whatever I did in my videos for data structure and few problems. These might be lead code problem. And I have another module for lead code, where you can see all these problems which I have solved till now, and I've created a video on all of them. So you can check out that playlist and you can go through the code. And yeah, do comment if you want me to do some specific video on any data structure, or you want me to solve any lead code problem. So that's it for now for this video. We'll see you in the next one. Take care. Bye.